Hello friends, welcome back to my YouTube channel Maths by Samit Deshmukh. So in this video we are solving example from miscellaneous exercise 2b of matrices, and in this miscellaneous exercise question number first is to solve objective type question, means multiple choice question, and in matrices more than 95% example can be solved using shortcut methods. So try to understand this shortcut method, and later on applying this shortcut method you are able to save your time also. So let us try to solve the example number first. If you are new on my channel, subscribe the channel and hit the bell icon to get notification of every newly uploaded video. So observe the example number first. In this question, one matrix is given to us and its adjoint is also given to us, but in this adjoint of A, two unknown values are given to us, A and B. Using this given condition, we have to find out these two unknown values A and B. So first try to understand how to find out adjoint of a matrix of order 2 by 2. Already I have given this as a note while solving the example also. So you, in case of descriptive method, you are not able to apply this shortcut method, but while solving objective type question, definitely we are able to apply shortcut method. So let us suppose that the element of a matrix are P, Q, R, S. Then adjoint can easily be found out. This method is applicable only in case of a matrix of order 2 by 2. So just interchange these two elements, S, P. PS is there, we are interchanging these two elements and change the sign of these two elements, means here we will get plus Q is there, replace it by minus Q, plus R will get replaced by minus R. Using this shortcut method we are able to find out adjoint. So here also matrix A is also given, and this is what? Adjoint, means which can be obtained by using this shortcut method, isn't it? So or we are able to apply this shortcut method to find out our required value. So if this is the matrix, then what will be its adjoint? So adjoint of A will be equal to, just simply we have to interchange these two elements 4 1 and change the sign of these two elements, means here we will get minus 2 and here we will get minus 3. Once the adjoint is known to us, but adjoint is already given, so by comparing these two matrices we can conclude that A is equals to minus 2 and B is equals to 1. So A is equals to minus 2 and B is equals to 1 is given in first option. So hope the idea about how to apply this shortcut method is very clear to you. Only interchange these two elements and change the sign of these two elements to find out adjoint of a matrix. Here matrix is given, we have seen how to find out its adjoint using this shortcut method, and then comparing these two matrices we have got our required two unknown values. Now see the example number second. In this case one matrix is given to us and we have to find out inverse of this matrix. So to find out inverse of a matrix of order 2 by 2, again remember one shortcut method. So if A, B, C, D are the element of the matrix A, so first try to understand this shortcut method. Later on you are able to apply it as a shortcut. You are able to apply it while solving multiple choice question. So its A inverse will be equals to, we know that formula of A inverse is what? 1 upon determinant of A into what? Adjoint of A, into adjoint of A. So this is the formula which you have applied to find out inverse of a matrix applying adjoint method. So 1 upon determinant, keep it as it is, 1 upon determinant, and we know that how to find out adjoint. Just now we have seen that while finding adjoint we are interchanging these two elements and we are changing the sign of these two elements, means here we will get minus B and here we will get minus C. So this formula is applicable as a shortcut method while finding inverse of a matrix. So let us apply this formula. 1 upon what? Determinant. What is the determinant of this matrix? 0 minus 1 means minus 1. Once the value of determinant is known to us, apply this shortcut method to find out what? Adjoint, means interchange these two elements. So here we will get 0 0 and change the sign of these two elements, means here we will get minus 1 and minus 1. Inverse is known to us, but if you will observe the option, so here this value is replaced in the option, means we have to simplify it. So what we will get here? 1 upon minus 1 is minus 1, and if I am multiplying by minus 1 to all the element, sign of all the element will get changed. So 0 1 1 0. So if we are multiplying by this minus 1, so we will get this matrix. Check that this is given in what? B option. So here B option will be our correct answer. Hope the method shortcut methods are very clear to you. Now see the third example. In this example, one matrix is given to us and it satisfies which condition, that A into its adjoint will be equal to Ki. Using this condition, we have to find out this unknown value K. So here remember one important condition, that A into adjoint of A will be equals to, in one example we have proved that its value is equal to determinant of A into I, isn't it? So A into adjoint will be equal to determinant of A into I. Already we have proved this condition in one example, but now remember this example, this condition we are applying to find out our required unknown value K. If we will compare this equation and this given equation, we can observe that K means what? K is nothing but what? Determinant of A. Means to find out value of K, K is coefficient of I, and here it is denoted by what? K. So K is nothing but what? Coefficient of I means determinant of A. Means to find out value of K, we have to find out value of determinant of A. So one matrix A is given to us, simply we have to find out its determinant. This product is 1 and this product is 4. 1 minus 4 will be equal to what? Minus 3 is the value of determinant, and value of determinant is nothing but value of K here. I think in the second exercise we have proved this condition, that A into its adjoint is equal to determinant of A into I. Now observe the next example. In this case one matrix A is given to us, then the adjoint of this matrix. Just now we are in the first and second example we have seen how to find out adjoint. While finding adjoint we are interchanging these two elements, means here we will get 1 and here we will get 2, and change the sign of these two elements, means minus 4 will become plus 4 and plus 3 will become minus 3. Using this simple technique we are able to find out adjoint of a matrix of order 2 by 2. So observe that this value is given in what? B option. So here B option will be the answer, and K is equal to minus 3, means D option is our correct answer here. Now see the question number 5. In this question one matrix A is given to us and which condition is given? A into its adjoint is equal to K into identity matrix. Just now applying this condition we have solved one example, I think example number 3rd. So now use the same method to solve this example. Using this given condition we have to find out unknown value K, but already we know that A into its adjoint is what? Determinant of A into I. So this is the result which is available with us. If we are comparing these two results, we can conclude that, or we can observe that K will be equals to what? Determinant of A. So K is equals to determinant of A, means to find out value of K simply we have to find out value of determinant. So let us try to find out value of this determinant. This product is 4 and this product is 6. 4 minus 6 will be equal to what? Minus 2, means here value of K will be equal to minus 2. Now observe the next example. In this next example one matrix A is given to us and then A inverse does not exist, means inverse of this matrix does not exist. It is given to us. If these conditions are satisfying, then our question is to find out value of lambda. Now to find out value of lambda we are using the condition that A inverse does not exist. A inverse does not exist means we can say that matrix is what? Singular, because we know that inverse exists if matrix is non-singular. Non-singular means determinant is not equals to 0, then matrix is non-singular, and non-singular matrix are also called as what? Invertible, means inverse exists. Means inverse does not exist if determinant is equal to what? 0. So since A inverse does not exist, so we can say that matrix is singular, means its determinant is equal to 0. So on this side keep 0 as it is, replace matrix A by, write down the element of matrix A, lambda 1 minus 1 minus lambda. So here let us simplify this determinant. This product is minus lambda square and this product is minus 1, minus and this minus 1 will become plus 1. This product minus this product, means first take product of diagonal element minus product of off diagonal element. We have got one equation, simplifying it we are able to find out value of lambda. Minus lambda square is equal to plus 1, on this side will become minus 1, cancelling minus on both sides. So lambda square is equal to 1 implies that lambda is equal to plus or minus 1. Simply we have taken square root on both sides. So in this way we have got our required value of lambda. If these conditions are satisfying, means matrix is singular, means its inverse does not exist. Now see the question number 7. In question number 7 one matrix is given to us and we have to find out inverse of this matrix. But here in this question here minus is not there. If you'll observe the question very carefully, so I am modifying this question. Either we are able to give minus here or we have to give the minus here. At that time only we will get the answer in this option. Means adjacent and inverse of this matrix is not given in any one of this option. That's why I am modifying this question. So I am putting minus here. So we have two choices, either write down minus here or write down minus here, so that we will get our answer here. So already we have used this formula as a shortcut method to find out inverse of a matrix if its order is what, 2 by 2. So which is equal to 1 upon determinant. Value of determinant can be find out orally also in case of matrix of order 2 by 2. So what is this product? Cos square theta minus minus means plus sin square. Cos square theta plus sin square theta. Cos square alpha plus sin square alpha will be equal to 1. Now to find out adjoint, we have one shortcut method, just interchange these two elements. So here also we will get cos alpha and here also we will get what? Cos alpha. Just simply we are interchanging these two elements and then change the sign of these two elements. Here minus sin alpha is there, so write down plus sin alpha. Plus sin alpha will get replaced by minus sin alpha, and here 1 upon 1 is 1, not necessary 1 here. So this will be our required answer. Here we can observe that, so it is given in B option. So here we can say that B option is our correct answer. Now observe the example number 8. In 8th example, one matrix F alpha is given to us. If F alpha in bracket alpha is given, at that time our every angle is what, in whatever maybe the trigonometric ratios are given in this matrix, their angle will be denoted by what? Alpha. Now we have to find out its inverse of F alpha. So let us check which option satisfies this condition. So let us check with the first option, F of minus alpha, means we have to replace every alpha by what? Minus alpha. So where this alpha I am replacing by minus alpha, so here also replace alpha by minus alpha. Let us see what we will get here. What is cos minus alpha? Will be equal to cos alpha. So here minus, keep it as it is. Sin minus alpha will be equal to minus sin alpha, and minus into minus will become what? Plus. Here 0, keep it as it is. Again replace alpha by what? Minus alpha. So sin alpha will become minus sin alpha. Here cos minus alpha will become cos alpha, because we know that the values of trigonometric ratios for negative angle. So sin minus alpha is minus sin alpha and cos minus alpha is cos alpha. So here alpha does not appear in another element, so keep this element as it is. So if we are simplifying it, what result we will get? Cos alpha minus into minus is plus sin alpha 0 minus sin alpha cos alpha 0 0 0 1. In this way we have got the value of F of minus alpha. Now here if we will observe these two matrices, easily we can observe that the elements are exactly same, only these elements are added. So in this case check that same answer we are getting, so we can conclude that this will be the correct answer here. But till if you want to check, if you want to verify whether our answer is correct or not, so use this condition that A into A inverse will be equal to identity. Identity means their element are 1 0 0 0 1 0 0 0 1. So if I am multiplying by first row to first column, let us check whether we will get 1 or not. So cos square alpha minus into minus will become plus, and minus sin alpha into minus sin alpha will become plus sin square alpha. Cos square alpha plus sin square alpha plus 0 will be equal to 1, means we are getting 1 here. If I am multiplying by first row to second column, let us see what we will get. Cos alpha into sin alpha is cos alpha sin alpha, and minus sin alpha cos alpha will get cancelled, so we will get 0. Here multiply by this row to last column, so this product is 0 plus 0 plus 0 will be equal to 0, means easily we can observe that our conditions are satisfying that product of these two matrices will be what? Identity matrix. That's why we can say that this answer will be the correct. Now let us check why this answer cannot exist. If we will observe here, alpha is replaced by what? Alpha raised to power minus 1, means let us try to find out element of F of alpha raised to power minus 1, means every element, every alpha will get replaced by what? Alpha raised to power minus 1, means cos alpha raised to power minus 1. In the same way again we will get remaining element also. If I am simplifying it, it will become cos alpha raised to power minus 1 can be written as 1 upon alpha also. In the same way here also we will get minus sin 1 upon alpha. are the element of this matrix. Here we will get sine 1 upon alpha, cos 1 upon alpha, and definitely their product cannot be equal to what? Identity matrix. So that's why we can say that this option is wrong option. So double angle is there. So if I'm replacing every element by double angle, definitely the product of given matrix and this new matrix cannot be identity matrix, because here angles are alpha and here what? 2 alpha, means double angles are there, so their product cannot be equal to identity matrix. So that's why C option will also be a wrong answer. So that's why here we can conclude that A option will be our correct answer. Now see the example number 9th. In this case we have to find out inverse of this matrix, and inverse of this matrix is I or A or A dash. A dash means A transpose or minus I. We have to check which of the following option is right answer. So I means what? Identity matrix. Just I have to express element of this identity matrix. Matrix of element A are already given to us. A transpose. A transpose means what? A dash means what? A transpose. While finding transpose of a matrix, we are interchanging rows and column. So convert first row into first column, convert the second row into second column 1 0 0, convert this third row into third column 0 0 1. And here we can observe that the given matrix and this matrix are nothing but what? Exactly same, means A and A transpose are equal, means we can say that matrix A is what? Symmetric, because here this condition is satisfying. And lastly, minus I. Let us try to find out element of minus I. Minus I, minus, keep it as it is. We already know the element of identity matrix, so we are multiplying to all the element of this identity matrix by minus, so we will get this new matrix. Now let us check which of the following is a inverse of the given matrices. We know that A into A inverse is always equals to what? Identity. Identity means its elements are 1 0 0 0 1 0 0 0 1. Just we are applying here tally method to check whether our answer is correct or not. So this tally method can be used as a shortcut method to find out inverse of a matrix. If options are given to us, hardly within 10 to 15 seconds we are able to find out our correct answer. So well, now A, and this is what? Its inverse. If this condition is satisfying, that their productive identity, then we can conclude that this first option is right. And if this condition is not satisfying, we can conclude that our first option is wrong. Let us check the multiplication of these two matrices is identity or not. So multiply by row to the column. So 0 plus 0 plus 0 will be 0, but what is our required element? 1. So this option is the wrong option. So here also we can say that let us check about last option. So 0 plus 0 and 0. So here also if I am multiplying by first row to first column, we are getting 0, but what is our required element? 1. So we can say that this option is also wrong option. So both the options are what? Exactly same. So we can say that inverse of this matrix, for this matrix, either inverse is A or inverse is what? A dash also, because both the matrices are exactly same. So coincidentally in this case two options are matching, means two options are correct options, isn't it? Why? Because element of both the matrices are same. But let us check whether our condition is satisfying or not, means that multiplication of these two matrices is identity or not. So multiply by first row to first column. 0 plus 1 plus 0. Yes, 0 plus 1 plus 0 is 1. Now check that second product is 0 or not, means we are multiplying by first row to second column. 0 plus 0 plus 0, yes, 0. Multiply by first row to third column. 0 plus 0 plus 0, means this product is also 0. 1 into 0 is 0 and 0 into 1 is also 0, means we are getting 0 here. Now let us check we will get 1 here or not. For that purpose multiply by second row to second column. So 1 plus 0 plus 0 is 1, means we can conclude that multiplication of these two matrices is identity. So here in this case here two options satisfies the condition that both are, we can say that both the matrices are inverse of the given matrix. Might be possible the mistakes happen here. ऐसा जनरली नहीं होता है कि दो ऑप्शन मैच हो जाए, लेकिन अभी यहाँ पे कोइंसिडेंटली क्या हो रहा है कि दो ऑप्शंस, हमारे दो ऑप्शन के एलिमेंट एग्जैक्टली सेम है. सो वी कैन से दैट बी ऑप्शन इज ऑल्सो राइट आंसर एंड सी ऑप्शन इज ऑल्सो व्हाट? राइट आंसर. Now see the example number 10th. In this case the inverse of symmetric matrices, we have to check that inverse of symmetric matrix is which matrix. So options are symmetric, non-symmetric, null matrix or diagonal matrix. So simply you have to remember that the inverse of symmetric matrix is always symmetric. Remember it as a note, but we will discuss it by considering one example. Let us suppose that A is one matrix whose elements are say 13, 2, 5, 5. In case of symmetric matrix, if you will observe the definition of symmetric matrix, there is no condition on diagonal element. कुछ भी ले सकते हैं आप diagonal element, लेकिन नॉन डायगोनल एलिमेंट यहाँ पे अगर +5 है तो यहाँ पे भी +5 ही होना चाहिए, यहाँ पे 2 है तो यहाँ पे भी +2 ही होना चाहिए. Means Aij should be equals to Aj. If this condition is satisfying, that Aij is equals to what? Aji. At that time we can say that matrix is what? Symmetric matrix. Let us try to find out inverse of this matrix. What is the formula to find out inverse? 1 upon determinant into adjoint of this matrix. So 1 upon determinant is 26 minus 25 is 1, and adjoint, we have one shortcut method to find out adjoint. Interchange these two elements 2, 13 and change the sign of these two elements. So here we'll get -5, -5. 1 into 1 is 1, so not necessary to write 1 here. Here we can observe that non-diagonal element, यहाँ पे -5 तो यहाँ पे भी क्या है -5. Means we can conclude that this matrix is what? Symmetric matrix. Means what we have seen, if A is one given matrix, that its inverse is also what? Symmetric. Well, now see the example number 11th. In this case, one matrix A of order 2 by 2 satisfies which condition? That A into adjoint of A is equals to what? One matrix whose elements are 10, 0, 0, 10. So which is equal to, if I am taking 10 common here, then what will get? 1, 0, 0, 1. Means which will be equal to 10 into, can I write it as identity matrix? So what result we have got here after simplifying given equation, that A into adjoint of A is equals to 10 into I. But already we will have one result, that A into adjoint of A, which we have applied in two example also, will be equal to determinant of A into I. If we are comparing this result we have got from the given condition, and this is the result available with us. Comparing these two results, what we can conclude, that determinant of A is equal to 10, and here also we have to find out determinant of A. So here we can say that determinant of A will be equal to 10 by comparing these two equations. Now let us try to solve the example number 12. I think there is some correction in this example, because this A dash represents what? Transpose of a matrix. And if you will observe all the options, किसी भी ऑप्शन का अगर हम ट्रांसपोज फाइंड करते तो ये रिजल्ट हमें मिल ही नहीं सकता. तो आई थिंक हियर इंस्टेड ऑफ A dash, here A inverse is there, so we have to make the correction that replace A dash by its inverse. Now inverse is given to us and we have to find out value of what? A. Now simply we know that whenever we are finding inverse, so अगर ये inverse है तो ये दो एलिमेंट क्या होंगे? इंटरचेंज होंगे. तो यहाँ पे रिक्वायर्ड मैट्रिक्स में ये 2 इधर होगा और 1 इधर होगा. सो इट सेटिस्फाइज इन दिस ऑप्शन आल्सो. और ये दो एलिमेंट के क्या चेंज होने चाहिए? साइन चेंज होने चाहिए. यहाँ पे दोनों माइनस है तो यहाँ पे दोनों प्लस होंगे, तो यहाँ पे दोनों भी प्लस नहीं है, यानी दोनों के साइन सेम नहीं. यहाँ पे ये कंडीशन सेटिस्फाई हो रही है. सो आई थिंक डी ऑप्शन विल बी द करेक्ट आंसर, मीन्स आवर रिक्वायर्ड मैट्रिक्स ए. लेट अस चेक वेदर इट सेटिस्फाइज द कंडीशन और नॉट. इफ वी आर फाइंडिंग इट्स इनवर्स, सो फर्स्ट वी हैव टू फाइंड आउट 1 upon what? Determinant. So here 2 minus 4 will be -2, and into adjoint. While finding adjoint, we are interchanging these two elements and we are changing sign of these two elements, means +4 will become -4 and +1 will become -1. And this matrix is given here, so we can conclude that, so this inverse matrix is the inverse of matrix A. So if I are denoting this matrix by A, then its inverse is this one. So here I think instead of A dash, A inverse is, not think, I am sure that here by it's a print mistake, यहाँ पे A dash दिया है टेक्स्ट बुक में. हो सकता है कि वो A dash के जगह पे क्या होना चाहिए? A inverse होना चाहिए, क्योंकि अगर A डैश है तो ये ट्रांसपोज होगा और चारों भी मैट्रिक्स का ट्रांसपोज ये नहीं है. लेकिन तो इसका मतलब यहाँ पे कुछ तो भी करेक्शन है. इफ वी आर रिप्लेसिंग डैश बाय इनवर्स, सो देन वी आर गेटिंग आंसर. दैट्स व्हाई आई थिंक हियर करेक्शन इज देयर. रिप्लेस डैश बाय व्हाट? -1. In this way we have solved all the 12th example from question number first. In the next video, we will solve the next remaining question from this miscellaneous exercise. Now, if you think that the videos are helpful to you, like the videos and share these videos with your friends also.